All right, so hi everyone. We are Queen's Hyperloop from Kingston, Ontario, and we're here to showcase our research project for Hyperloop Global. So a little bit more about the team. Our sub-team is composed of around 20 undergrad students, 3 of which are here to showcase this project today. So I'm Thomas. I'm one of the AI sub-team co-managers. And
I'm Eunice. I'm the other AI/ML sub-team manager.
And I'm Aaron. I'm the business competitions manager for this year.
yeah, so a little bit more about Queen's Hyperloop. So our team is composed of 3 different branches: the technical subsystems, which is who create the physical design of the pod, and they're composed of propulsion, chassis, suspension, braking, power systems, control systems, and systems design. And then we also have research and development, which is composed of the materials and LIM team, as well as the infrastructure research team. We're currently working towards designing a track here in Kingston, and hopefully we'll be able to host Hyperloop Global in the future, as well as the business and logistics team, which is composed of sponsorships, marketing, logistics, and business competitions. And business competitions is Aaron's team. So in terms of our growth as a team, we started Queen's Hyperloop in 2015 with only 30 members, and we've since then grown to 167 members this year. And our sub-team in particular is just a fraction of Queen's Hyperloop as a whole, as we consist of 5 different branches and 16 different teams, which are all students here at Queen's. And we have competed in various competitions, including Hyperloop Global last year, as well as European Hyperloop Week, which was in Edinburgh, Scotland. So I'll now pass it on to Aaron to dive into our research project for the year.
Alrighty, thanks, Thomas. So just a brief overview of our research project. The research project that I'll be working on with Thomas and Eunice, so between business and the AI teams, will be to design or to find the most optimal Hyperloop network within North America. So we'll be touching on that for a little bit throughout this presentation. And what we'll be talking about is just a brief problem that kind of inspired this project, what our overall research objective is, some relevant factors we should consider, and how we plan to integrate our AI model. So just to start off with a problem, when we think about where to implement Hyperloop tracks or a Hyperloop network within North America, there are many challenges to consider. We have to assess a synergy between large cities, how they may cooperate together. We have to think about the overall community and economic impact, and how we can integrate it with current transit infrastructure, such as subway systems, such as high-speed rail. And from a business perspective, there's so many roadblocks for them to consider. For example, can they even make money from it in the near future, possibly even long-term future? Can they comply with all the regional regulations, even in the same country? And whether even enough people will actually make use of the Hyperloop system. So this is one big question to ask yourselves, but we can break it down into many other smaller questions. For example, with cities, which indicators really suggest that a city is ready to adopt Hyperloop? And it's not necessarily city size or population. What shared characteristics make 2 cities ideal for a Hyperloop connection? And what we realized is it's not necessarily just the distance between them or whether they're in the same region. In terms of community impact, which cities' economies can Hyperloop impact the most? And how does that tie with sort of the demographic trends? How do demographic trends influence whether it can actually grow in the future? And in terms of integrating with existing transit, which existing, for example, subway systems, rail systems can support or feed into this Hyperloop system? And which urban development plans are most compatible with integration? So in short, Hyperloop route planning, it's a really complex puzzle. There's economics, there's geography, there's even human behavior in general, and we have to consider all of them to see which cities are the most ready for Hyperloop. So on to our overall research objective. So our main goal is just to develop an optimized Hyperloop network in North America that strategically connects economic hubs, balancing local benefits, and how we can integrate it with regional transit systems. So the overall success criteria, one is obviously technical feasibility. A lot of it has to do with geography and the varying landscapes. Another is financial viability, which largely depends on demand and seeing whether enough people will actually make use of the Hyperloop system, and scalability. When we think about connecting, for example, cities A or cities B, it's not just about the most urban or metropolitan areas. We're also thinking in the future about suburban and rural regions. So some of the relevant factors that we've come up with so far boils down to geographical, demographic, and infrastructure. Obviously, this is not an exhaustive list. Over the next few months, we'll be coming up with a lot more factors that we possibly haven't thought of as of yet. But there's terrain and different landscapes. Even, for example, in the same region, for example, Los Angeles and San Francisco, they have differing landscapes. And it's not so easy just to connect two cities that are close together with Hyperloop. There's natural reserves and biodiversity, which includes entrenching on protected land, and ease of land acquisition. Even two points close together, it's not easy. It's much easier to acquire perhaps one piece of land versus another. In terms of demographic, we also have to think about labor market flows. Just because two cities may be close together doesn't mean they correlate a lot in terms of mutual economic benefit. And also equity and access. Distance in cities doesn't mean that they have the same wealth. There may be a huge wealth disparity, and we need to make sure that they can all take advantage of that same Hyperloop network. And there's also urban sprawl, population growth, which kind of ties in with infrastructure. We have to ask ourselves, if we were to construct a Hyperloop network between two big cities, how can we complement the existing transport systems? And are we able to use that to scale in the future to its surrounding, perhaps smaller areas? Our strategic objective overall is just once we consider all these key factors, which can be a really long and complex list, we can finally lay down the groundwork for sustainable and economically viable Hyperloop network. And now I'll pass it on to Thomas and Eunice to touch more on how we can integrate our AI into this project.
Yeah, thank you so much, Aaron. So as you mentioned, part of our goals for this project is to develop an optimized Hyperloop network that can strategically connect key cities. And we plan on realizing this through a shortest path algorithm and relevant geographic, demographic, and infrastructure factors previously discussed by Aaron. So our current approach is to use the A-star algorithm, which will be further explored in this presentation. And with this model, we'll be able to train and test it based on the predetermined factors. Then from this data, we will then be able to actually visualize what the Hyperloop routes will look like and then draw conclusions from the algorithm. So I'll now pass it on to Eunice to further discuss the model's integration.
Thanks for that amazing introduction, Thomas. So when we're integrating the AI model into this project, we can kind of break down into 3 different pathways. And so our first stage will be primary research. During this, we will be undergoing a data process and data cleaning just to ensure maximum model efficiency once we do input the data that business competitions team will provide with us. And during this stage, we will also ensure that we are using this time to determine significant geographic locations to represent the nodes. The overall goal of this project is to create a graph neural network, also known as a GNN, to represent the relationship between the nodes and the edges, where the nodes are these significant geographic locations and the edges will represent the paths and the relationships between them. Moving into our next stage, we'll have a weight allocation. And so this consists of using the primary research that was cleansed and processed in the previous stage to assign weights to each node and edge. These values will therefore reflect their respective significance and interrelationship within the framework of the Hyperloop transportation system and its overall feasibility. If you look on the graph on the left, you can see an example of a GNN, a graph neural network, where the nodes are represented by the circles and the edges are represented by the lines highlighted in yellow. These weighted edges will show the influence and the favorable or unfavorable conditions of the paths between these geographic locations. So an example of an unfavorable path would be something with large natural formations such as mountains, and favorable conditions can be things like high population density or high socioeconomic class. Our final stage will be evaluation. So using the A-star algorithm that Thomas has previously introduced to determine the shortest path, as we are currently still in our primary research stage, we haven't yet to determine whether this optimal path will be either a minimum or maximum value, but that will be determined once we finish our primary research stage. And then finally, we'll be conducting a comparative analysis of the outcomes across the different evaluated parameters that Aaron and Thomas have already mentioned. And this is just to deduce the correlation and the influence between each of these factors and the optimal pathway. So we're using this to determine whether certain factors have an overpowering influence on our optimal path, or if other factors have negligible influence and therefore don't need to be considered within future models. And just to go over our final and overall timeline for the year, as we've mentioned in the past, we are a team of undergraduate students. So we are doing this in addition to our course load at school. And so within the fall semester, which is happening currently, we are just establishing our research criteria, gathering our primary data, and building our base model. Moving on into our winter semester, which starts in January, we're hoping to train our model based on our data and research, and also compile our findings. And then finally, within the summer of 2024, we're looking to output sample North American Hyperloop networks and determine the optimal paths between these regions. So that concludes our presentation. We really do appreciate everyone taking the time out of their day. And so we are wondering if there are any questions.
Thanks for the presentation, guys. Nice work. Any questions from anybody? You can raise your hand or you can pop it in the chat. All right, well, thank you so much, Queen. So it's awesome. We are a little bit ahead of, oh, Kevin. Kevin has a question. Let me read it out for us. So where do you source your training sets for the current stage?
So currently for the current stage, we're still doing our primary research into the different types of models. So obviously there's different types of models that we can use. And so A-star was one of the kind of the findings of our research. For our test cases in particular, there are like large public databases, especially for states that are like really technically logically advanced, such as California. So we're looking into those kind of data sets now, and then potentially also using kind of optimal data sets. So they might not be real life data, but more kind of synthetic data to train our model as an initial round, and then train it more as we continue to research into government regulations and population densities through like public available information sites.
All right, thank you, Queens. That was great.